Welcome to our webinar series for Spark. And today we are going to talk about five things one should know about Spark and must kind of thing. So we are going to talk about the Spark basically, and we are going to talk a couple of features that Spark has compared to other big data tools that we had. And we are going to relate it like how it's going to enrich the data analytics or especially the big data environment by using these features of Spark. And as part of this demo, as part of this webinar, I'm also going to show you a demo that will be basically about Spark streaming. So how you can process a stream of data using Spark. That's like one of the key feature that we will talk in slide as well. And then we will see as part of the demo also where we will stream a data and then we'll see like a Spark can handle that stream of the data and can process it. So we'll talk about that as well, right? So that's what we are going to have this webinar. So we are going to divide it in two parts. First, we will go through the slides. We'll see these features and then we will have a demo where we'll talk about Spark streaming. Okay, and in case if you have any question, feel free to put that on question window. And towards the end of the presentation, I will take the question and I will answer that. Okay, so let's get started and let's talk about Spark for a minute and then we'll see about a couple of features related to Spark. So if you talk about Spark, right, so it's the next big thing that we have in our big data processing after Hadoop. So it's more, like if you talk about Hadoop, right, so it has been a kind of a dominant kind of technology in big data space in last couple of years. And a lot of good thing that has emerged from the this whole Hadoop ecosystem is about this Hadoop distributed file system that we had. So that's right kind of the storage for all the large volume of the data. Second thing, we had this yarn that's like kind of at another source negotiator. So that also basically gives you a good kind of a framework for managing the big data resources and the computation part. But then the challenge that still remains, guys, with the Hadoop is about the volume, about the speed part of this one, so velocity. So when you talk about Hadoop, or when you talk about the big data problem statement, it has three things. One is volume, another one is variety, and the third thing is about the velocity. So Spark is one of the key feature of the Spark is about the speed, right? So how you can speed up this whole processing of the data. So that's one of the key thing that Hadoop brings in. And apart from that, other thing that Hadoop has is like it has a lot of specialized kind of the tools for different kind of processing. While when you go with the Spark, right? So Spark being a cluster computing platform, so it's designed for more like fast as well as general purpose kind of system. And on the speed side, if you see, so Spark is going to extend the popular MapReduce framework that we had. And that's basically gives you a kind of way to work on a different kind of computation, whether it's like interactive querying, stream processing, so all those kind of things you can work now with the help of Spark. So we are going to see here, in terms of a Spark is like how you can use Spark for in-memory processing and how Spark does that one. We are going to talk about the Spark streaming support, and we'll also talk about like how Spark basically uses these machine learning and the graph processing on the Spark core platform. And then we'll talk about very interesting concept related to the data frame API. Spark has now support for data frame, and using that you can process your data in a kind of a tabular form. So we'll talk about that. And then the key thing about Spark is that it's not a kind of a tool that works in isolation. So you can integrate it easily with the Hadoop, and you can use all the data that you have in Hadoop along with a Spark to faster processing as well as to get the insight from the data. So we'll take one by one and we'll talk about that, right? How Sparks basically leverage all these features to give you the faster kind of analytics, right? So first we are going to talk about Spark in-memory processing and how it's going to basically speed up this whole set of processing that you're going to have. Okay, okay. So if you guys have worked in a kind of a Hadoop kind of ecosystem, and if you have used MapReduce, so one of the thing that you have in case of MapReduce, guys, is like if you want to use MapReduce, you write your map or reduce job, and then you submit it, and it just goes ahead, runs the mapper, runs the reducer, and that's what you get the final output. So in terms of if you see the execution part, so MapReduce has basically no awareness in terms of the total pipeline that you are going to execute. So each step is going to execute in isolation. And every step, like if you talk about the mapper output, it just goes ahead and store that on the disk, and then again in the next step, it will go ahead and read the data in reducer and process it. So these kind of things, it becomes challenging, right? If you are going for some kind of a machine learning algorithm, or where you need to you do a lot of iteration in terms of the data. So there are a lot of algorithm which keep running on the data and keep tuning that one. So like if you take the example of a recommendation engine or any kind of a neural network that basically work on a data in a very intuitive way, right? So if you are trying to basically get some kind of model that need to be trained. So in that case, what you will do is like you will have some kind of data set that you will be keep feeding to your model, and then based on that it will keep training the data. Now, what you'd like to do here is like every time you read the data, you see like what's the the error that it's going to give you, and then you based on that you keep tuning the data and keep adjusting this stuff. So they call it like wash, rinse, is repeat until you get whatever you are looking for in terms of the answer. So if you have to implement such kind of algorithm, right, it becomes very difficult with going with MapReduce kind of framework, which will basically go ahead and read data every time from the disk, and it will write it back. So in case of a Spark, what it has is it has a very powerful kind of mechanism that can keep this stuff in memory. So it has a very powerful caching and disk persistent capabilities. So using this, what it will do is it will allow you to cache, even if you can go for raw data. So you can cache that raw data also in memory. And since it has like all these distributed kind of component which can go ahead and store the data, so it has concept of distributed worker. So using that, when you keep the data, when you keep persist the data in memory, you can basically do all these kind of computation much faster than what you can achieve using the MapReduce kind of framework. So that's one of the thing that you should be aware about the Spark is like it can leverage memory for caching the data, and then using that particular caching, you can go ahead and process your data in much faster way than what you would have got from the disk, right? And to do that, what Spark has, guys, is it has a concept of called RDD, so that is for resilient distributed data set, right? So this RDD, what it helps you is like it helps you to create a kind of storage in memory, which can be used for all your further processing to directly interact the data from memory. And apart from that, Spark also has support for this streaming kind of application. So if you have a stream of the data that is coming to your system, so you can use Spark streaming feature to basically get all these data, and you can create RDD on top of that, and you can run analytics as well. So, like if you guys are familiar with the architecture terms, right? So Spark is going to support both kind of architecture. So we call it like Lambda architecture. So both like batch as well as the real-time processing you can do on top of a Spark. Right. So this is one of the features of Spark that you can leverage. And when you go with such kind of implementation in Spark, where you are leveraging Spark-based computation for processing the large volume of the data, the key benefit that you see is like faster processing. So that's where like a Spark is sometimes it's called 100 times faster, right? Than what you have with the MapReduce kind of processing. And you can see here like one of the Spark co-founder, right? So what he found is like when you're using Spark and you're trying to sort around 100 terabyte of the data using a data on the disk, it took around 23 minutes. And if you compare that with like whatever the record that we had with the MapReduce with 2100 machine, it took around 72 minutes. So it means like you can run the data much faster and with less number of machines. So that's where like footprint in terms of the number of machine that you need and kind of speed that you get is much better than what you have in with the traditional processing with Hadoop based kind of platform. Now, if you talk somebody about right who has just heard about Spark, right, and how this Spark works. So one of the thing that you will have is like people talk about Spark is that Spark is only good for the data that can fit in memory. And believe me, guys, this is like one of the what we'll say is like greatest misunderstanding that you will have about this Spark. So, like talking that Spark is only handling the data set that can fit in memory, and else it will going to crash. It's not correct. So this is a kind of a underlying mistake in terms of understanding about the Spark. So what the feature that people talk about in memory processing, it's basically Spark by default tried its best so that it can fit the data in memory, and then from there it can process the data. But if it's not able to handle that, if the data set is too large to fit in memory, what the Spark will do is it will automatically create these stuff or spill these things on the disk. And this is like one of the the cool thing that you have a Spark is called graceful degradation. So this will basically move the data from memory to the disk so that you can do the processing even on the large data. Now, how you can use this Spark feature is, guys, like if you add or if you give more RAM to the Spark, it can done it can do your processing much faster than what you will get with the less RAM. Because if you have the less RAM, it will be more like a kind of a Hadoop kind of system where it will put the stuff on the disk and then it will process. So Spark need for the memories basically to speed up. So if you give more memory, it can keep more and more data in RAM, and from there it can do the computation. So it will be much faster than what you will get uh, like having the data on the disk and reading from there and processing it. Right. So just make sure you guys are clear on this one that Spark is is going to leverage basically both memory as well as disk when it's going to come to processing. So it's common misconception is Spark is only for in-memory processing. So from its inception, Spark was designed to be a general kind of execution engine. So when you talk about general kind of execution, guys, so this is like also one of the key feature that you have with the Spark. So Spark comes with something called a Spark core. So using this Spark core, what you get basically is you get um, kind of the generic side of this whole processing. And when you say generic, it's basically designed to cover all the kind of the different kind of distributed systems that you would like to use. So whether it's a batch operation, iterative algorithm, interactive querying, streaming. So all these kind of stuff you can use on a Spark because it provides you an engine called a Spark Core that supports all these kind of the different workload. So it's going to be a win-win kind of both, like the people who are writing the application using this. So for them also, it's going to be quite easier because you're going to learn about one platform, about one particular uh, programming style, and then using that, you are going to execute all these different kind of the workload. And also from the management side, maintaining instead of a separate tool, you can go ahead and use one Spark core-based engine that can do all kind of processing. Cool. So I'd like to pause here for a minute, and I'd like to take question. If you guys have any question here in terms of Spark, so do let me know, guys. So I think there are some question already here. So what is RDD, Manishankar? It is for resilient distributed data set. So that's what we have, RDD. And why Spark should be used in why Spark should be used in HDFS? Only in HDFS? No, it can integrate with Hadoop as well as it can work with other kind of storage as well, Shrikant. So there has been a lot of integration in terms of the kind of system it can support. So it can work with your Hadoop yarn-based scheduler. It can work with its own standalone scheduler as well as Meso. So it can support different kind of cluster as well. And in fact, Spark you can download on your laptop and you can work from there as well. So it has all these different kind of interface as well. Difference between MapReduce versus RDD versus data frame. Okay, sure. So RDD, it is for resilient distributed data set. So that's where you have like when you keep the data in memory, and if you lose that particular machine, I'm not sure how Satya, I think, right? So Satya, right? So you basically have a chance to lose that particular data set. So with the RDD, what you have is you have kind of a linear graph. So using that linear graph, it exactly knows how to get the data back. So you can always get that data back. So that's where the term resilient it comes, right? So it knows how to recover from failure. MapReduce, it uses disk, so that's where it has performance kind of hit. And in terms of data frame, so if you are dealing with the structured data and if you want to use a lot of kind of SQL kind of processing and column kind of stuff, so that you do with the help of support of data frame. So if you come from R or from Python, so there's something similar on that line. So you have the concept of data frame. And Shrikant says, I know Spark code run on a select query will hardly confine 5-6 line, whereas Hadoop, yeah, extend 50 line. Exactly. And that's the reason Shrikant is, in case of a Spark, mostly we'll use the language Scala. And Scala is being a functional language, so it's going to basically speed up this whole stuff. And as well as it's going to make your code very concise. So you are just going to write a few lines of the code and rest all the things it will be taken care. Yeah. Java also has a support, but the example that you have mentioned, it's mainly for yeah, for Scala, right? So it makes your code very short. Okay. So moving on. So next we are going to talk about Spark streaming. And Spark has a lot of support for the streaming data as well. So you can do a lot of processing on the stream of the data. So streaming is basically a process like when you are going to continuously receive an input data and in terms of discrete units and that you need to process. So if you talk about like real life example about the streaming, so like video, audio kind of the content that generally you download in terms of movie or watch you on YouTube. So what they do is instead of giving you the complete content, generally you stream the data and you keep consuming each stream while playing that video or audio. So apart from this, right, multimedia example, right, there are a lot of use case for the streaming data, guys. So like if you work on, marketing feed, right, so market feed, weather data, stock trading. So a lot of use cases are there where you need to react on the data or process the data in a faster way. So those kind of application, if you want to build, you can build it using a Spark-based system. And all these systems that I'm talking about, like whether you're talking about a stock trading or kind of multimedia data or any kind of market feed you want to analyze. So all these data are going to be on large volume of the data that you're going to have, and it's going to require a kind of system that can handle such large stream of the data and can process. So with this Spark, what you have is you have a kind of engine which can go ahead and process this kind of real-time streaming data. So it has a concept of called D-stream. So that's for discrete stream that you are going to get, and it's going to be converted, into a series of RDD, and that's you are going to process it. And in terms of your processing logic that you are going to have, guys, so it's going to be much similar than what you had in terms of your normal Spark processing. So using the same kind of understanding, using the same kind of the logic, you can easily process your stuff in Spark streaming, as well as with the other stuff like Spark batch processing. So similar logic you can use in both places. So apart from that, right, support for in-memory analytics and the streaming data. Spark also has a lot of support, guys, if you want to work on a kind of a machine learning kind of a stuff. So machine learning is like when you want your machine to take the decision, when you want your machine to uh, process the stuff and do a lot of kind of classification, regression, clustering. So those kind of a stuff you can easily do on top of a Spark, because Spark has MLlib libraries. So using these MLlib library, right, which contain all these common machine learning algorithm, you can do a lot of kind of these kind of machine learning processing on top of Spark, right? So Spark has support for this one. So all these stuff, right, in terms of classification, regression, clustering, collaborative filtering, you can do with the help of Spark Core Engine as well as Spark MLlib. And the best thing that you are going to get is like a couple of these algorithms are going to work on the streaming data as well. So like if you are familiar with regression, right? So linear regression and all, you are going to just apply on the stream of the data. So that's going to be a kind of game changer when it comes to doing running these kind of machine learning algorithm on live stream. So the next thing that we are going to talk about, guys, is about cyclic data flow. So if you talk about the MapReduce, I think somebody has the question like comparing MapReduce versus RDD, right? So in case of MapReduce, when you compare MapReduce, so in case of MapReduce, what you have is like you submit your job, your mapper task runs, that writes the data to the disk, reducer reads the data, writes the output, and then finally you get whatever the processing that you wanted to do on the data. But in case of a Spark, it's quite intelligent, right? So in case of a Spark, once you submit your Spark job, so until you submit so in Spark you have two things called transformation and action. So until you want some kind of action to be done, right? It's not going to execute anything, right? So when you submit your kind of action, like if you're doing a word count, so first you tell read the data, filter it, split it. So all the steps that you are going to specify, Spark is not going to do until you say count. So when you submit the command called count, then only it will go back and it will go ahead and start executing all these tasks that you want to do as part of a Spark execution. So, having that particular stuff, the way Spark works is like it's going to create a DAG, so that's directed acyclic graph, and it will exactly have an idea like what problem that it's going to execute or what kind of statement that you have provided, and based on that, it does a lot of internal optimization, guys. And if you're doing some kind of filtering, and if you have a data set, you have created an RDD. So what it will do is it will just go ahead and fetch whatever the data that's needed to support your processing. So that way, since it has the visibility, end-to-end visibility, like what kind of task that you want to execute, so it goes ahead and optimize in terms of operators, how it's going to use it, and what kind of the data set that it want to bring it in memory. So that's another feature that you have with the Spark, right, where it uses this DAG kind of stuff uh, to optimize your whole execution flow. Streaming data, yes, we can see that, Manish, in some of the webinar. Definitely, we can see that, right? So apart from these things, guys, like streaming support, in-memory, machine learning, and having the complete view of the data, the next thing that we are going to talk about is Graphx, right? So Spark has support for a lot of graph processing as well. So Graphx is basically a library for manipulating the graphs. Like nowadays, a lot of data that you analyze is basically kind of the social media data that you get. And to analyze that, like if you want to get the Twitter data and you want to understand who are the influencer in a particular city or in a particular group, you need to build a kind of a graph, and based on that graph, you want to come to a kind of insight or conclusion. So in case of a Spark, like you have the support for Spark streaming and machine learning, Spark also going to support Graphx. That basically going to extend the Spark RDD API that we have. And using this API, it can go ahead and create the directed graph with kind of the different kind of property that you can attach in terms of the vertex and edges. So apart from that, it also Graphx also provides you to various operator for manipulating the graph. Like if you want to create a subgraph, if you want to create a map vertex, you can go ahead and do that. And it has also a lot of library for common graph kind of algorithms like page rank, triangle counting, connected components. So all these kind of libraries are also going to be available as part of the Graphx. And this was like one of the limitation that we had, guys, on MapReduce is if you're using a MapReduce platform, if you want to do any kind of graph processing, converting that into a MapReduce kind of algorithm is very complex than what you get in terms of Spark. So Spark has been built to support all these kind of the application as well. Right. So that's what another key thing about the Spark is like it is going to support all these graph processing algorithm as well on the same Spark core engine, which will support streaming, in memory, and machine learning kind of algorithm. So the next thing that we are going to talk about is Spark, guys, is about support for the data frame. So this is something which came like later in terms of the Spark, right? So this data frame is going to be similar, like if you guys have worked on R or Python, so it's going to be inspired by the data frame in R. So data frame API is basically designed to make this whole big data processing on tabular data easier. So if you're dealing with the structured data and all, you can easily do with the help of data frame. So data frame is a kind of a distributed collection of data that you're going to organize in the named column. And on top of that, it's going to provide support for a different kind of operators on this, like filter, group, aggregation, right? So all those kind of the things you can do with the help of Spark SQL. And the context, like in case of a Spark SQL, you're going to write this stuff in terms of the SQL. So that's again going to make this whole processing much easier because you don't need to learn all those complex Java kind of processing like compared to MapReduce. So here you can still bring your Spark SQL, you can bring your SQL expertise, and then you can get much faster processing than what you get with the Hadoop and Hive kind of thing, right? And you can also integrate it with, like, if your data is already in Hadoop and if you have the Hive table there, if you have metastore created, so you can use that, you can integrate with that one. And you can like if you have any of the existing RDD and you want to write some kind of a Spark SQL application, you can do all those stuff, right? And the good thing about the data frame, guys, is about the scalability part, right? So it can go ahead and scale from KB to petabytes of the data, and it has support for wide array of the data format and different kind of a storage system as well, and a lot of optimization. So they came up with something called catalyst optimizer in case of a Spark SQL, so that basically to enhance the SQL processing on top of Hadoop. So generally with the Hive, you have the limitation how much you can enhance that whole processing. They did some days and all, but finally Spark SQL is the one which speed up this whole processing in much faster way. And it has a kind of seamless integration with the existing big data tool, right? So that also there, and also with the Spark, right? So you can do that. And in terms of a Spark, right, another key thing that you have is like it has support, like multi language support you have. So you can use Python here, you can use Java, you can use Scala, and now with the Spark 1.4 onwards, you have the support for Spark R as well. So all these kind of integration also, it makes easier for the people to basically get the stuff and easily get started in terms of working on Spark. Which is best for Scala or Python? I have a question from Shyam here. So Since the Spark framework has been written in Scala Sham, and also the key features first get available in Scala, then it get ported into Python. So yeah, the Scala is the one supported. Like if you talk about streaming and all, so streaming and all came in Python much later than when it came in Scala, right? So if you are looking for the latest feature, and that's like one of the things nowadays people go for, so Scala will be more preferred one. However, if you come from a data science background and if you're already familiar with Python, so then easiness will be with the Python. So it has both the aspect in terms of ability of the feature as well as the easiness to work. So in both the parameters, you need to take the decision based on this. What's the difference between Spark and the Hadoop data flow? Spark, Sharaf, right? So what it's going to do is it's going to keep the data in memory, and from there you can iterate. While in case of Hadoop MapReduce flow, it will always move the data to the disk, and from there it will do the processing. Okay, so that's about the data frame. And next thing about the Spark is, guys, Spark integration with the Hadoop. So in case of a Spark, it has support for all these different kind of the cluster. So it can work with a standalone cluster. It can work with Mesos. So Mesos is going to be again open source cluster manager, and it's going to be developed. It is getting developed by again the people who have initially started Spark, right? So UC Berkeley University, it's getting work, and it again uses a toolable kind of the scheduling mechanism where you have Mesos master which decide how many resources to offer for each framework, and then each framework is going to decide like what the resources it's going to accept and for which kind of application. So it has support for Mesos, it has support for HDFS. So HDFS being yarn on top of it, so it is going to work on that. So you can run a Spark on a Hadoop cluster that has yarn enabled, and it can also run in standalone mode. So that's like Spark comes with a standalone scheduler as well. So that also going to basically take your input data set, and it can process it using the Spark code engine. Right. So in terms of Hadoop, if your data is already there on Hadoop, you can easily have a Spark running on that, and then it can process the data. So if you see Spark, right? So a lot of use case guys for Spark, right? So if you so this is the quick survey that has been done, right? So if people were asking about the languages, so around 88% users responding that they are using Scala. Uh, some 22% people Python, right? So that's what it is. And Java is also there, but nowadays with Java and with all this Java 8, people are also finding it similar, kind of the Scala, the functional kind of stuff. But yeah, still most of the use case is in Java. And a lot of people, right, 30% people are kind of evaluating Spark now in terms of processing, and 20% are planning to use Spark. They're planning to use Spark in 2015, and that trend is going to continue in 16 as well. Right, and a lot of use case for the Spark is, guys, where people want to replace MapReduce with the Spark-based processing, and the reason is for faster processing on the larger data set, right? And a lot of use case for the Spark is, guys, if you guys work on complex event processing, so CP kind of engine, if you want to develop, you can do with the help of a Spark, right? And most of the users, it's around developers. Then we have some set of data scientists and some other experts, but most of them are in terms of developers. And a lot of industries using here, so retail, banking, telecom, IoT, Internet of Things. So all these are the use case where domains where people are using a Spark-based solution. And there are different kind of the use case people are going for the Spark. So it's like user-facing services. It's around 36% people. Recommendation system. A lot of use cases for BI. The traditional BI people are not doing in much faster way. Data warehousing kind of use case, like where you have your data and then you want to process it with these kind of Hadoop-based engine. People are also moving from existing EDW kind of system to now Hadoop-based system and trying to leverage Spark. A lot of use case cases for the log processing and as well as like fraud detection and security systems. So especially if you work on telecom, if you do CDR analytics, so a lot of analysis goes in terms of how to detect all those fraud calls, and that's getting terminated to the different destination. So all those kind of things you can do, retail, banking, so all those kind of algorithms where you need to use sufficiently large amount of the data and that you want to do in quicker time frame, you can go ahead and use a Spark based application. Okay, so these are the use case, right? Common, and all of these will need the kind of its own problem statement, what you want to implement, and then designing the whole pipeline in terms of the data and how you can process it. So a lot of companies using Spark, guys. So you name the any big company which is dealing with the data, they are basically using these Spark-based system to handle in terms of the data, like Verizon, eBay, right? So telecom like Cisco, Netflix, right? So a lot of use case, Yahoo and other stuff definitely. So next what we are going to do here, guys, is we are going to see a quick demo in terms of the streaming data that we have. So here are a couple of references, guys, that we are providing you in terms of, like, if you are more interested in terms of reading about the Spark, so you can go ahead and use this. So we do have all these references that you can spend, and we do also have the course from Edureka, right, which provides you the both this Spark and the Scala kind of learning. So it's going to be again kind of both like the Scala and the Spark you can learn as part of this uh, Big Data Spark course that we have, and it's kind of 24-hour live class with 20 hours project work and 24/7 live support that you will have. So here we are going to now switch over and we are going to talk about streaming data. And I'm going to show you a demo where you can go ahead and use the sort of a stream to process in terms of a Spark. So what I'm going to use here is I'm going to use this Spark virtual machine that I have here, which is provided by Edureka, right? So this is what we use in terms of our sessions that we conduct on Spark. So when you talk about streaming, right? So it has a couple of basic stuff that you need to understand, right? So when you talk about streaming, it is like how what's the rate of the data that you are going to get. So data rate is there. So that can be like how many KB per second, MB per second, or GB per second. So that's the data rate that you're talking about. And a lot of use case about this Spark is, guys, about like I talking about like CP, complex event processing, where you take your data set and you process it on the stream of the data, and then based on your insight that you get on the stream of the data, you take the decisions, right? So in terms of Spark, Spark is going to have a lot of support for all these streaming stuff. So all these streaming libraries are going to be provided to process the data, to process these live data. And your stream can be from anywhere, like you can get the data from Twitter, Kafka, or some kind of port that you're listening. So from all these stuff, you can go ahead and have the data. And Spark has it's something called a streaming context, which is going to basically wrap around all these Spark context that we have. So that's going to be act as a kind of entry point for your Spark streaming functionality. And what it's going to do have, guys, is it's going to have a concept of called batch interval. So using this batch interval, it is going to take this Spark stream data, process it in that particular interval, and then it will create RDD, which will be processed by the Spark core engine, and you will be able to basically handle the stream of the data. Right. So here, what we are going to do here, guys, is that we are going to use one example where we are going to use a Spark for processing the data set. And for that, what I'm going to use here is I'm going to start the Spark. So if you want to start the Spark, you need to go to the Spark installation directory. So this is the directory where we have the Spark here. So we'll just go here and okay, and if you click here, so you will have a bin directory. So go to bin, and if I do ls-l, so you see here a Spark shell. So we are going to start the Spark shell that will give us a kind of interface using which we will do the processing. So here for the demo, what I'm going to use is in one of the window, I'm going to run the Spark, and while in another window, I'm going to start the streaming application. So I will use basically try to stream the data from this tab, and just give me a sec here, guys. Okay, I'm going to start the data from this tab, and hold on. And then we are going to receive that data in the Spark streaming context, and then we'll see how it aggregates the data. So to start with, first you should start the Spark, right? So how you start the Spark is you have something called a Spark shell, and let's go ahead and give some extra memory here so that it runs. Okay, so we'll give 1 gig of memory so that it can start. So let's hit enter, and it's going to start the Spark shell, guys. And then we are going to go ahead and give some Spark specific instruction which will be used here. So let it get. So how many of you are familiar with Hadoop, guys, or with the Spark basics? Are you guys from Hadoop background? Okay, perfect. So you understand about how the big data processing happens. Okay, perfect, Manisha. Okay, so you have this Scala. So let's go ahead and clean this screen. So we'll do Control L. So now what we are going to do next here is we are going to import some Spark streaming related import. So we are going to do that. So I'm just going to paste it here quickly. So we are going to import Spark configurations and Spark streaming and storage and all the storage level. Right. So then what we are going to do next here is we are going to import some conversion, implicit conversion as well. And then we'll create the streaming context and where we will basically go ahead and use the batch interval that will give us like what window we want to process the data. Right. So I'm going to go ahead and use all these implicit conversions as well. So now what I will do is I will go ahead and create a kind of streaming context with a batch interval, 2-second batch interval, and in that interval only we are going to process this stream of data. So every 2 seconds, whatever the data is going to come, we are going to process it in this one. So we have a Spark context that we are streaming context that we are creating, and we are giving streaming context and second as 2. Hit enter. So this says streaming context has been created, right? So now once this is created, so what we are going to use here is we will use a kind of a socket text stream of the data. So that's where all these discrete stream of the data we will get from the local host, and we will use port 8585 where we are going to receive the data, and we are going to keep all these data in memory. So we are going to specify all these stuff, and we are going to create basically this socket text stream stuff for getting the data on this port called 8585. So this is where we will be sending. So I will start my netcat server on that one, and from there I will stream the data. So I need to tell Spark like from where to get this data. So I'm going to tell where lines and SSE is the Spark context that we created, and socket and stream and localhost. If you are getting this data from some other machine, give the IP address of that machine, and then 8585 is the port. Hit enter. Right. So this has been created. Now, what we will get here, guys, is basically we will get a input line here. And what we are going to do as part of this one is it's going to basically take these input lines and it's going to count it, right? How many words we have entered. So as soon as the stream of data comes, it will give us the count in that particular batch interval. So for that, I need to go ahead and split the input line into different words. So if you guys have done the Hadoop stuff, you know how to split input line to do the word count. So something similar where we are going to use basically a flat map to convert. So flat map is again a kind of feature that you have in case of a Spark. So it's going to do words flat map and lines dot flat map, and we are going to split based on the space. So I'm going to feed a line on a particular port, and that line will be split on different word, and that's we are going to count it here. So we do the split here. And once this is done, so next we need to write the logic, like how you want to do the count. So we are going to output 1 for each of the occurrence of the word, and that need to be aggregated. So that part I'm going to do here. So we are going to have a word map and going to basically each word as we split, we are going to mark it as 1. And then what I'm going to use here is I'm going to use something called reduce by key method. So it is going to add the number of occurrence that we are going to have for each word based on a particular key, and then it will give us like the final count that we are interested in. So we are going to have this word count and reduce by key, and that's what we are going to add these numbers here. Hit enter. Okay, so so far all this transformation, guys, and if you see here, Spark has not done anything yet, right? So until you start some kind of action, right, which when you submit it or when you ask it print, it's not basically going to go ahead and do anything. Okay, so next we are going to ask it to print the stuff. So we ask for word count.print and hit enter. Okay, so now what we will do next is, so far we gave all the logic to the Spark and we created a Spark streaming context. Now basically we have to start it, right? So we have just created it. So we need to start the Spark streaming context that we created. So we have to do ssc dot start. And once we do this, it will basically go ahead and start the Spark streaming context, and it will start waiting for the data. The data need to be basically fed here so that it can go ahead and process it. So we are going to start that. And to do this, guys, what I'm going to use is I'm going to use a netcat server, and from where I'm going to feed the data here. So I'm going to use this, so Control L, and I'm going to start my netcat server here. Okay. So now I'm going to feed the data from here. So like if I give here to be or not to be, okay. So like the data I'm going to feed on this terminal, and this data need to be coming to this Spark streaming application, which is basically going to take this data and count it. So do ssc.start. Okay, so now it's basically waiting for the data, right? So every 2 seconds it will wait for the data. So let's go ahead and feed couple of these data set here, guys. So hit enter, keep pasting the data set, right? So as the data is coming, it will keep going to the Spark application, right? So a couple of lines that we have. Now, if you come here, it's basically getting all this data and processing it, and it's basically counting all these input data set. So if you go ahead and feed more data here, right? So you can see this. So now if I go ahead and terminate this stuff, right, where I go ahead and do, right? So you should be able to see all these count, guys, right? So how many times in that window it has come, to be or not to be, right? So B came twice, 2 came once, right? So all these it has counted. If you go each context, whenever it has received the data, it will do the counting. So in one of the line, I think I just typed this one, right? So it has counted as per that as well. So not 2 times or 2 times, B to 1 times and 2. This is where you can see now, right? So if it is, this is like your live stream data is coming from your user, what they are doing on their site, right? So if they are clicking one particular ad, so if you're like Amazon kind of thing, you can stream the data, and based on whatever the user has clicked that stuff or how many times it has clicked, you can show new kind of offer or new kind of product to that particular user. So all these stuff you can do on the streaming data, right? So you can just feed the data to Spark and it can process it. So a lot of like use case guys you can build based on this streaming data, and basically deciding on like what the window length that you want to process. You can adjust this whole stuff. So whether you want to go for 1 second, 2 second, 1 minute, and depending on like what kind of cluster you have, it can go ahead and take that data, create RDD, and it can process it very easily. Right. So here, all these stream, discrete stream that we are going to get, it is going to basically allow data to be pushed from the external system and which can be processed. And apart from the printing the data that we are seeing here, you can also create like do save as a text file, save as an object file. So a lot of things also you can do in terms of all these streaming data that you are going to get here. Right. Okay. Is data stored in HDFS, Munish? Yes, you can go ahead and store this data as well. So it has support for that. Okay. So that's about a quick demo, guys, of how Spark processes streaming data, right? So that you can go ahead and use this Spark for. Right. So if you have any question, query, please go ahead and let us know, right? And then we can take it here. And also, guys, towards the end of this webinar, you are going to get a survey form. So please fill that and do let us know how much it was useful and what you guys would like to see in future. So we can take that one. So please take a moment to basically go ahead and respond to the survey. And if you guys are interested, we do have Apache Spark and Scala course, which is going to start on 21st December, and it's going to be a weekend batch. So if you're interested, you can go ahead and register for that as well. Okay, so let me know, guys, if you have any question, and thanks all for attending this webinar. So it was kind of a pleasure to host all of you here. Yeah. So go ahead with your question, guys. So where do you integrate this streaming data into? So now you can use two-way, Manish. One, you can publish all these kind of aggregation that you're doing to some kind of port, right? Some API you can give it, and from there your system, your recommender system can read the data and can do that. Or you can use some kind of servicing layer here from where you can keep storing the data. So there are a lot of storage system, in-memory storage systems are there, and that you can give it to your recommendation system to basically take it and decide on like what will be the next set of output values or next kind of the predicted values you want to have. Is this data stored in HDFS? If you want, you can store it. Yeah. Meena, go ahead with your doubt. What was the, okay? If we have petabytes of data, then we need to have that much RAM to keep up on speed. Saying if the data goes on the disk, will it be slow? Yes, if you have the data. Two things, Meena, here. One is uh, if you have a large amount of the data, what you are going to do there, what you are going to do there is you're not going to work on the whole petabytes of the data. So finally you will need a kind of process data that you will interact in iterative way, so that you can store in RAM. But yes, if it is too much data, then it has to spill on the disk, and from there it can process. Okay. And while reading data from stream, does the data go through HDFS and data? No, when you have the streaming, Manish, you can directly connect it to Spark streaming. So like if you're getting data from Kafka, you can just directly feed it to Spark streaming context. So no need to go on data. If you want the data to be used in historical purpose, then of course like Kafka and other channels, you can write on the disk, like, or if you're using Flume, you can put the data on disk. So that way you can handle it. Okay. Visualization, a lot of new things are coming, Shyam. So like Zoom data and all, right? They have very good kind of visualization that you can use. Can we do join, aggregation, grouping? Or yes, you can do all those kind of processing, Minaji. Okay, any other question here, guys? Can we use it for live reporting in banking industry, multiple channels? Uh, Manishankar, can you help me, like what kind of the data you're going to get? So if you are going to get the data in terms of the stream, and if you want to do some reporting on top of it or any kind of CEP kind of thing, yes, you can do. Netcat server, do you need to? No, this generally comes with Linux, or you can use it any Kafka or other application as well, Manish. Yeah. Spark streaming user distributed? Yes, that's what the Spark streaming is, right? Otherwise, you have all other data streaming as well. Internet banking, mobile banking. Yeah, so a lot of stuff, and especially in the banking, you would like to react on the data as quick as possible, Manishankar, right? So definitely Spark is going to be use case. Yeah. Okay. Any more question here, guys? So feel free to reach us, and yeah, if you guys are more interested, we can definitely connect further and we can talk about this. Spark is streaming and the storm. Okay, so you had the storm before Spark streaming was matured, Manish, right? So Spark, this Apache Storm was there. But the best thing about the Spark streaming is that you get a unified platform where you can do both batch as well as streaming. And while in case of Storm, it's going to be two different applications. So Storm uses something like it's on like a spot boards, those kind of concept. So it was becoming challenging for people to maintain these two kind of system. While with this Spark streaming, you have a combined unified platform that you can use it for doing both kind of jobs. So you have a lot of consistency in terms of the batch as well as the stream processing. I can send you in the Spark system for that for use. I'm doing this. Sure, definitely, Manishankar. I think we should be able to help you. Yeah, definitely. Maybe you have to come to the support, but yeah, okay, cool. Perfect, guys. So we are on time. So thanks all for attending this webinar, and I hope you guys got a kind of quick insight in terms of some cool features that Spark has, and it gives you kind of you know uh, idea how Spark can handle the streaming data. Yeah, and my email ID, Panishankar, is chetan@edureka.co. So I'm just sending it. So yeah, you can use it. Perfect, guys. So thank you.